Stars are the most recognizable astronomical objects in the universe. At the heart of these stars, just like the Sun, are raging hydrogen atoms that fuse into helium, which makes stars radiant. What if I told you that there is a star out there that is fueled by a black hole at its core? Imagine the Sun, but 1,000,000 times bigger, and at its core, a horrifying black hole. This is a quasi-star, or what some call a black hole star. A mind-blowing star that existed early in the history of the universe. Is it possible for a star to be powered by a black hole? How did they form? In today's video, we are going to uncover what we know about the enigmatic quasi-stars. What really is inside a star? Before we dive deeper into the intriguing quasi-stars, we must understand what exactly is within a star and what really powers them. There are billions of stars in the Milky Way galaxy alone. We can see some of them in the night sky, but the one star that we are most familiar with is our very own Sun, which shines bright in the morning sky. Stars, like the Sun, are formed from an accumulation of gas and dust. Gas and dust are scattered throughout the universe, and when these collapse due to gravity, a star will be born. A familiar example of an aggregation of dust clouds is the Orion Nebula, which is a nursery of some of the brightest stars. As the cloud collapses, the material at the core begins to heat up. The scorching hot core at the heart of the collapsing cloud is known as a protostar and will one day become a real star. As the star continues to evolve, the hot core will get denser as it continuously accumulates gas and dust. A star the size of our Sun takes around 50 million years to grow from the beginning of its existence until adulthood. Our Sun will stay in its mature phase for approximately 10 billion years. Stars like our Sun are mostly made up of hydrogen and helium gas. In the core of the star, the temperature and pressure are so extreme that hydrogen fuses into helium. This process releases vast quantities of energy and makes the star shine brightly. When a star runs out of hydrogen to fuse, the star will die and will turn into a supernova. So basically, stars are giant exploding balls of gas consisting of hydrogen and helium. But in the case of a quasi-star, it is vastly different. Aside from them being unimaginably enormous, their cores take it to the extremes. The unimaginable quasi-star. Quasi-stars are very fascinating. It is a hypothetical star that is believed to have reigned supreme in the early phases of the universe. It is no exaggeration when I say that quasi-stars are tremendously gigantic. They were larger than any star we have ever discovered, and at their core was an immensely dense black hole. To put into perspective how big quasi-stars would have been, let's take the radius of our Sun. The radius of our Sun, which fills the whole solar system, is 432,000 miles, 696,000 kilometers. That is approximately 100 times greater than the radius of our planet. But wait until you see the largest star that our scientists ever spotted, the remarkable Quasi-Scuti. Quasi-Scuti is an extreme red hypergiant in the constellation Scutum and is almost 5,210 light-years away. Quasi-Scuti's radius is terrifyingly big, at around 730 million miles, 1.18 billion kilometers. That is 1,700 times greater than our own Sun. In fact, you could fit over 5 billion suns within this hypergiant. What if I told you that this hypergiant is nothing compared to a quasi-star that scientists think existed in the early ages of the universe? Quasi-stars were extraordinarily huge, towering almost tens of billions of miles in diameter. So, what exactly is a quasi-star? A quasi-star is a star that existed in the very initial stages of the universe. Unlike other stars that are driven by nuclear fusions, a quasi-star is powered by an infinitely dense black hole. So, why do scientists believe a star this extreme existed in the first place? Is it even possible for a star to be fueled by a black hole? The problem with supermassive black holes. Black holes are one of the most famous space objects. There are black holes out there that are incredibly huge, and scientists cannot comprehend how they were created. They believed that a quasi-star would hold the secret to their unusual upbringing. The real nature of black holes is unknown. We do not know what is within a black hole, but we are sure of one thing. They are extraordinarily dense. When a huge star has consumed all of its hydrogen at its core, it would immediately die and explode, marking the end of its life cycle. This explosion is what we call supernova. When a star implodes, it will collapse itself into an immensely small point, eventually forming a black hole so extremely dense and a gravitational pull unimaginably powerful. These black holes are classified into 4 types. The first one is a stellar black hole, which is relatively small. Stellar black holes originate from collapsing stars. The second one is the intermediate black hole. As the name suggests, the black hole is not too small and not too big. It is classified as an intermediate black hole if its mass is in the range of 100 to 1 million solar masses. The third type is the primordial black hole. These are hypothetical black holes that were supposed to exist when the universe was extremely young, just seconds after the Big Bang, a period in which stars and galaxies weren't even born yet. These black holes could range from approximately 100,000 times less than the mass of a paperclip to roughly 100,000 times the mass of the Sun. They could be incredibly tiny black holes or gigantic ones. The fourth type is the black hole that we're talking about, the supermassive black hole. These are black holes that existed in the core of every galaxy and are millions or billions of solar masses. For example, the black hole at the center of the Milky Way, Sagittarius A, has 4.3 million solar masses. There is just one problem with these enormous black holes. As you may know, black holes become bigger when they eat or absorb other masses like stars and planets. The problem with supermassive black holes is that it would take longer than the universe's current age for black holes that started as dead stars to become this big. Scientists, though, have an answer. The quasi-star. Is a black hole-powered star really possible? We indicated that supermassive black holes seem to be significantly older than the universe in terms of the rate that it is expanding. That won't be possible because, as we assume as of today, there is nothing before the Big Bang, only an infinitely dense singularity. Then, how did these supermassive black holes become this big? Scientists have devised a theoretical answer for the problem of supermassive black holes. They hypothesized that in order for supermassive black holes like Sagittarius A to form, gigantic stars existed in the early phases of the universe that had a black hole at their core. In the initial stages of the universe, quasi-stars were born from huge gas clouds loaded with hydrogen and helium. The clouds produced protostars, youthful, clumsy stellar bodies that continued to acquire more material and evolve. But these massive protostars did not have the high temperature it required to spark fusion at their core. You know what else can intensely heat up the gases inside? Gravity. When the core of one of these gigantic protostars collapsed, it would turn into a black hole. This black hole on its turn would begin to suck in matter from the bounty of gas and materials surrounding it. Because of the black hole's great gravitational pressure, it would release heat to power the star, taking the place of a normal fusion process. But shouldn't the black hole just devour the star? Well, yes, it will start devouring the inside of the star. But since quasi-stars are so huge, the outside layers will remain intact even though there is a vicious black hole fueling and devouring it from the insides. Ultimately, when the star dies, the black hole grows into the supermassive black holes we observe in the universe. This is the quasi-star, an enormous star caging a symbiotic monster within.